students, we were discussing the LR circuit and we have nearly completed the derivation for this LR circuit. We have seen so many equations that we can write, and now students, we will see in today's class, we will see the power generated in this particular LR circuit. Okay, so students, before moving to the derivation for the power, so let us recall that what was the power factor in this particular circuit. Okay, so I'm writing it here. Power in the LR circuit. Okay, so what was our in the derivation the power factor, the value of power factor, that is cos theta part is equal to r by z. Just go back to the derivation page. All right, so when our power factor is this, so just recall the value of power, that is the power generated in this AC circuit is what? P equals to half V naught I naught cos theta. Okay, so let us put the value of cos theta here. One thing students, that this V naught part I'm writing in this way. Just see how I'm writing as I naught Z, and the rest same thing by putting the value of cos theta. I will explain one second, don't worry. Okay, instead of writing the V naught, I've just used this value, that is I naught Z. Understood? Half I naught Z. I naught Z is for your V naught, and the rest thing, that is I naught, I have written here also I naught, and for the cos theta I have written R by Z, because your cos theta's value was your R by Z. Okay, so let us short it, let us reduce the term, so it will be half I naught square, Z and Z will get cancelled and will be left with only R. That means half I naught square R. Clear? Again, in this part I can write it in this mathematical form, that is I naught by root 2 whole square R. I can write this, just see, because root 2 into root 2 will give you 2, so I can write this in this way. Okay, so finally what I can draw, that is your P will be equal to I square RMS R, isn't it? I can write this, the final thing. So this means that the power that is dissipated only in the resistance R, because in the equation of this power, students, only which term is there? Only R part is there. So the power is dissipated only in the resistance R. So current through the inductor is wattless. Understood? Okay. So we have also seen that the derivation for the power in the circuit, and we have also seen that the current through this particular inductor is wattless. Whatever power is dissipated, it is only generated in the resistance R. Okay, so now students, we will move ahead to our next circuit, that is your CR circuit. Okay, so before moving to the CR circuit, let us draw the CR circuit. Let us draw the circuit diagram for CR circuit. This is your C part. This is your R part. This is the current flowing. This is the alternating voltage. This is the direction of the current, and this is the voltage drop you can see due to the capacitor, that is I am marking it by VC, and this is the resistive drop due to the presence of the resistance, that is marked as VR. Understood the circuit diagram? It's very clear. Alright. So here you can see the combination of both the C, capacitance and the resistance. Okay. And the voltage drop and the alternating voltage also. This is a source. Okay. So here this way your CR circuit will look like. So let us start by the usual way that we write the derivation, that the alternating voltage applied to the circuit, that means this part in equation form, how we can write as V equals to V naught sine omega t. This is the alternating voltage applied to the circuit. Now students, let's see that at any moment, if Q be the charge stored in the capacitor C, that means at any time some charge will be stored in the capacitor C and let it be your Q, then the effective voltage in the circuit will be what? That means your effective voltage is denoted by VE, which will be equal to V naught sine omega t minus Q by C. This is the effective voltage, students. We have seen this effective voltage in the previous circuits also. Alright, so now students, let's get back to the Ohm's law. Okay, now what did the Ohm's law said? That V equals to IR. That means here also we will use that concept. So effective voltage will be equal to, let us combine these two equations, that is V naught sine omega t minus Q by C will be equal to I by IR. Okay, I'm just putting the value of VE here in the case of in the Ohm's law, that is V equals to IR. So your V naught sine omega t minus Q by C will be equal to IR. Okay. Okay. So after this, how can I write, students? Just let us represent it in some mathematical form. I'm bringing this Ri here plus 1 by C into Q, which is equal to V naught sine omega t. I'm pushing this in the RHS part. Okay. Okay. Now let us assume, students, that Q values is equal to Q naught sine omega t plus alpha. I'm writing it here. Q equals to Q naught sine omega t plus alpha. Okay, this we have to assume. So therefore, if this is your value of charge, that is your Q, then I can draw the equation for the current. I can write the equation for the current. What is the equation for the current? I equals to dq by dt, isn't it? Which is equal to omega Q naught cos omega t plus alpha. Understood? Because your I means